Thank you for the opportunity to present here the space activities at Masaryk University. So, Masaryk University has an ambition to develop excellent space research. And the good news is that we have the support of the leadership of Masaryk University, of the rector and vice-rectors, as well as the leadership of the relevant faculties. The relevant faculties are the Faculty of Science, but also Faculty of Informatics and Institute of Computer Science. And the main topics in the area of space research is astrophysics using satellites and ground-based telescopes. This is what we do at the Department of Theoretical Physics and Astrophysics. We are also involved in the development of both large and small satellites for astrophysics. At the Faculty of Science, the geographers are interested in remote Earth observation, image processing, data analysis, modeling and interpretation of satellite data. And Masaryk University is a member of the Brno Space Cluster. So, I'm at the Department of Theoretical Physics and Astrophysics, where I lead the High Energy Astrophysics group. And our involvement in big satellites is the involvement in the Athena mission. I am a member of the Athena Science Study Team, which is basically an interface between ESA and the scientific community, which has a scientific interest in this L-class mission of the European Space Agency. We are also involved in hardware development for Athena, together with other subjects in Brno. Our group is doing giant force simulations of the Athena charged particle diverters. So the missions like XMM Newton and Chandra have a problem that protons, which originate in the sun, they enter through the optics of the satellite, and when these protons hit the CCD detectors, these protons cannot be told apart from X-ray photons. So the background in these satellites is very, very high. So to solve that, Athena is supposed to have a magnetic diverter where these protons entering through the optics will be diverted and basically into the walls of the satellite, out of the optical path. And our group is doing giant force simulations of this process. Some years ago, we also proposed a mission which we call Camelot, CubeSat array for measuring and localizing transients, together with colleagues in Hungary and in Japan. The idea is that gamma ray bursts, which follow the origin of stellar black holes, can be also observed with small satellites because they are very, very bright. And if we would have a fleet of about 20 satellites distributed uniformly on a low Earth orbit, then each part of the sky would be always continuously seen by at least 3 CubeSats. And so we would not miss any gamma ray burst in the future. But also, between these satellites, there would be a time difference when they detect this gamma ray burst. And from this time difference, we could infer the position on the sky where gamma ray burst happened, and we could warn other astrophysicists where to point their telescopes. So when we came up with this idea, we didn't have, of course, the funding for this mission. So first we secured funding to develop the detector for CubeSats. This detector was launched last year on a satellite that we call GRB Alpha. And this year, 2 gamma ray burst detectors were launched also on the satellite VZTelusat 2. These gamma ray burst detectors detected their first gamma ray bursts. So these are some of the gamma ray bursts seen by GRB Alpha. These are actually the first gamma ray bursts observed with this class of satellite. Our detectors don't only detect gamma rays, they also detect particles on a low Earth orbit. So they are actually also mapping the particle environment on the low Earth polar orbit. Here you can see the South Atlantic anomaly, you can see the polar rings. VZTelusat 2 also already detected 5 events. 3 of these were gamma ray bursts, 2 are solar flares. So this just shows that these events can be routinely observed not only by big satellites, as has been done until recently, but also with CubeSats. Next year, further CubeSats that are supposed to observe gamma ray bursts will be launched. We are part of the Hermes collaboration, which is an H2020 project, and within this collaboration, there will be 6 CubeSats that will be launched on an equatorial orbit, and there will be 1 more CubeSat, originally originating from Australia, that will be launched to a polar orbit. Hopefully, this mission will fly next year, and we will have more data to analyze. Then our recent project that I'm actually very proud of is QVIC. We proposed this project responding to a call for an ambitious Czech science and technology mission. This is led by VZTLU, which is the prime, and we are responsible for science of this mission. And the other partners are TopTech, which is developing the telescope for this satellite, and PKSat, which is responsible for communication. And the main goal of this satellite is UV photometry of so-called kilonovae. Kilonovae originate when 2 neutron stars merge. Then we observe gravitational waves. And there is and basically this merging of neutron stars is responsible for the origin of elements around us that are heavier than iron. So QVIC is a UV space telescope. The diameter of the primary mirror is something close to 30 centimeters. So the collecting area is 200 square centimeters. The field of view is large, around 2 degrees, and the primary objective is the photometry of kilonovae detected by gravitational wave observatories. These observations need to be performed within a day of this event, so the satellite will have capability for a relatively fast repointing. The microsatellite with the mass of up to 100 kilograms is being developed by the Czech Aerospace Research Center, VZTLU. And as I said, we at Masaryk University are responsible for science, for the science of this mission. Since the number of kilonovae that can be observed per year is very limited, it will be probably just a few. The estimates range from a few to a few tens. There will be a lot of other science that the community can do with these satellites, with this satellite. The science that we will be able to do will be rich, and the scientific community in the Czech Republic and also around the world will benefit from this mission. In our Department of Theoretical Physics and Astrophysics, there are astronomers who are also using satellites like Gaia, Kepler, TESS, and also small satellites called Bright. They use them for photometry of stars. Then the Department of Geography at the Faculty of Science is interested in Earth observation. It actually has long-term experience in the use of satellite data in environmental applications. The main areas of research are use of satellite data and data from drones for addressing global change, monitoring and modeling of environmental change, modeling of adaptation mechanisms and adaptation strategies, and modeling in the field of precision agriculture, use of remote sensing data in virtual reality. And the main tools is software for satellite data processing, and the satellite data are from the Copernicus program. Then the Institute of Computer Science is also interested in interpreting the data from Earth observations. It has experience in interdisciplinary cooperation, including the field of processing and analysis of environmental data. Their main areas of research is development and operation of powerful computer systems and data processing, and they specialize on demanding calculations, big data techniques, machine learning, and artificial intelligence. Their main tools are applications and developments of big data analysis tools, data infrastructure, and creation of new solutions. They have a prototype of the Envision portal, which unfortunately has the same name as the new Venus mission. And the Faculty of Informatics is interested in image processing, including remote sensing images. Their main area of research is image segmentation. Main tools is artificial intelligence, and current challenges include big data, many dimensions, modalities, including spectral, and they work on possible optimizations for speed and for hardware requirements. Thank you for your attention.
Thank you very much for a nice overview. Is there any question? Yes?
It was very nice talk. To your last slide about the imaging processing, yes. So are you running some cluster, or more precisely the Faculty of Informatics, or how are you doing it? Because it's your own research, it's not related to Google or companies like this, or is it?
So I am unable to answer this question because I am not involved.
Okay, any more questions? If not, then let's thank Norbert again.